Welcome, deep divers. Today we're embarking on, well, a truly cosmic journey. It takes us light years away, but it really brings us closer than ever to answering one of humanity's biggest questions. Are we alone? For decades, finding true Earth twins, it felt like searching for a specific needle in a cosmic haystack. This deep dive is all about some new research that might just be handing us a very, very sophisticated metal detector for finding those needles. We're diving into fascinating new findings, specifically a study from astronomers at Heidelberg University and their groundbreaking work with the CARMENES project. Our mission today is really to unpack what these discoveries tell us about the sheer abundance of Earth-like planets out there, and crucially how this might radically reshape the ongoing search for life beyond our solar system. You might actually be surprised by just how common certain types of planets are turning out to be. Okay, so let's dig into the core insight here. The headline is, well, it's incredibly exciting. New research suggests that small rocky planets, the kind we often associate with potential life, they may be far more common than we ever imagined.
Particularly around a very specific type of star.
Exactly. And what's truly fascinating here is that this study zeroes in on these small, low-mass stars known as M-dwarfs. To give you a sense of scale, these are stars that have less than 1/6 the mass of our sun. Tiny, really. Not only are they lightweight, but they are also, by far, the most common type of star in our galaxy. So their prevalence, combined with these new findings, makes their potential for harboring planets just incredibly significant. It sort of shifts our focus, from maybe searching for rare Earth twins around sun-like stars to looking at potentially abundant rocky worlds around these super common stars.
Right. And the key to unlocking these discoveries wasn't just observing, but some truly cutting-edge technology. What's the secret weapon here? Tell us about the CARMENES project and its incredible spectrograph.
Yeah, the secret weapon, if you will, is the CARMENES spectrograph. It's located at the Calar Alto Observatory in southern Spain. It was actually designed and built back at Heidelberg University's Königstuhl Observatory. This instrument, it's incredibly advanced, specifically engineered to scan M-dwarfs for these tiny, subtle wobbles in their motion.
Wobbles? Like the star itself is moving.
Exactly. These tiny shifts are caused by the gravitational tug of orbiting planets. They create minuscule changes in the star's light, or rather its speed towards or away from us. Astronomers detect these by precisely measuring the star's speed using a high-resolution spectrum and analyzing its spectral lines. Think of it like reading a star's unique barcode or fingerprint. Each line tells us something about its movement and composition. This whole technique, it's called the radial velocity method.
Wow. Okay, so you've got this incredibly precise instrument staring at these very common dim stars looking for tiny wobbles. So with all that technical power, what specific gems did CARMENES actually unearth in this particular study?
Well, for this specific piece of research, the team selected 15 stars. They chose them from a much larger catalog, about 2,200 M-dwarfs that are part of the wider CARMENES program. And by meticulously analyzing their radial velocity data, all those wobble measurements, they pinpointed and confirmed the existence of 4 new planets.
4 new planets, just from those 15 stars. That's a significant haul. And what kind of planets are we talking about here? Give us the specifics.
Okay, so the largest of these new planets is quite substantial. It has a mass about 14 times greater than our Earth, and its orbit is quite long, takes approximately 3.3 years to go around its star. The other 3 planets, though, they're much closer in size to Earth. Their masses range from just 1.03 up to 1.52 Earth masses. Very Earth-like in size. And they have much, much shorter orbital periods whipping around their star in just 1.43 to 5.45 days. Really fast.
Okay, wait, that 14 Earth mass planet, that sounds pretty big. Is it still considered Earth-like in this context, or are we more interested in the smaller ones when we think about, habitability?
That's a great question. It really highlights the nuance here, doesn't it? While a 14 Earth mass planet might be rocky, it's definitely getting into a size range where it could hold onto a very thick atmosphere, or perhaps even be more like a mini Neptune rather than a true super-Earth. So yeah, you're right. The real excitement generally for potential habitability focuses on those smaller ones, the 1 to 1.5 Earth mass range.
Okay, that makes sense.
And when we connect these specific finds to the broader picture, the statistical analysis they did is, well, it's quite revealing. They show that stars with less than 1.16 solar masses, these really tiny M-dwarfs have, on average, about 2 planets with less than 3 Earth masses orbiting them. As Dr. Adrian Kaminsky from the Königstuhl Observatory put it, he stressed, and I quote, "It is quite remarkable how often small planets occur around very low-mass stars."
Remarkable indeed. 2 planets per star, on average.
Yeah. And conversely, larger planets, like that 14 Earth mass one or even bigger, they seem to be rarer around these tiny stars. So this strong correlation suggests that low-mass stars, they predominantly form smaller planets, often in these close, rapid orbits we saw with 3 of the discoveries.
Right. Which, okay, brings us to the big question, the one everyone's thinking about. What does this actually mean for finding truly habitable worlds? We've heard about thousands of exoplanets over the years, something like 5,000 now, right? But that elusive true Earth twin has remained just out of reach. Does this new data get us any closer?
It absolutely does. You're right about the 5,000 or so planets discovered previously, and none has been a perfect twin of Earth, meaning, a perfect match across all key criteria: mass, radius, surface temperature, and orbiting a sun-like star. However, these newly discovered planets, especially the smaller ones, they meet at least the first 3 criteria: mass, radius, and potentially a surface temperature that could support liquid water, depending on the atmosphere. And that really is a significant step forward.
Okay, so mass, radius, temperature, getting closer.
Exactly. And it raises that important question: why are M-dwarfs themselves so promising for the search for life, beyond just having lots of small planets? Well, small rocky planets in the so-called habitable zone, that Goldilocks area, around a star where water could exist in liquid form, they're the prime candidates, right? And because M-dwarfs are so incredibly common, and crucially, they radiate their energy very constantly over billions, even trillions of years, they could provide incredibly stable environments for the development of life over vast geological timescales, much longer than our sun will last, actually. So this finding, it really provides concrete clues as to where the search for habitable planets could be most promising. It points a big arrow towards these M-dwarfs.
That long-term stability sounds incredibly promising. It definitely broadens our horizons beyond just looking for sun-like stars. But, I know some researchers also raised concerns about M-dwarfs, things like intense stellar flares or the planets being tidally locked, always showing the same face to the star. Does this research offer any insights into those potential challenges? Or are those still separate hurdles we need to consider?
Those are indeed crucial separate considerations and absolutely valid points. This specific study focused primarily on detection and the statistical prevalence, just how many planets are there and what sizes. So while it doesn't directly address the flare activity or tidal locking issues, the sheer number of these small planets it confirms around M-dwarfs makes these systems just too compelling to ignore. It basically tells us we need to redouble our efforts to understand those specific environmental conditions, the flares, the radiation, the tidal locking, because that's where so many potentially rocky worlds seem to be.
So it raises the stakes, in a way, makes understanding those challenges even more critical.
Precisely. And, it's also just incredible to think about the global effort behind discoveries like this. This study, sure, it was led by Heidelberg University, but involved researchers from Bulgaria, Germany, India, Norway, Spain, the USA, and supported by multiple international funding bodies. It really is a testament to how science works best collaboration across borders.
Absolutely. It takes a village, or maybe a planet, to find another planet. So wrapping this up, what does this all mean for you, the listener, curious about our place in the universe? Well, this deep dive into the latest exoplanet research reveals that the cosmos might just be teeming with small, rocky worlds, orbiting the most common stars in our galaxy, no less. It kind of shifts our perspective, doesn't it? From hoping for these really rare cosmic coincidences around stars like our sun, to understanding that the basic building blocks for potentially habitable environments might be far, far more abundant than we ever imagined.
Exactly. This new data, it nudges us closer to understanding the statistical likelihood of life existing elsewhere. It's not proof of life, of course, but it points us strongly towards where to look with greater precision. It makes the search for life in the universe feel a bit more focused and perhaps a bit more imminent as an endeavor.
So think about this as you go about your day. If M-dwarfs are so common and small, rocky planets are apparently so common around them, maybe our very definition of habitable needs to expand beyond just Earth's exact conditions. Could life thrive under a dim red sun, maybe in a tidally locked world? And what new technologies, what new ways of thinking might we need to truly explore these myriad potential homes for life out there? Definitely something to ponder as you continue charting your own course through the cosmos.